A very good morning to all. I'm Siddharth, second year IT, and I and Devjit would be the instructor for today's forum of C++. A special note of thanks to the team of Pionix for providing me with the opportunity. This is the second day of the forum, and let's get started. After covering the basics of C programming and starting off with the competitive programming, let's move forward with algorithms. What are algorithms? First, I would be talking you about the two algorithms just to give you out the basic idea of algorithms. What are algorithms? How algorithms are used? Why algorithms is used? Why can't we use? So, first we need to print out the HC. Okay. First take. Already we have seen how to check if a number is prime or not. We have already covered in that video how to check if a number is prime or not. Let's move forward with that. After a number is checked with a prime number or not, then suppose I am giving you 100 number, and 100 number needs to be checked if it is prime or not. 1, 2, 3, 4. Again, the same loop would be running 100 times. Okay. Then, after that, if I tell you to print out prime numbers from Google Docs, Excel. Okay, this is fine. Okay, now if I tell you to print out prime numbers from 1 to 100, now the brute force or the naive approach to this would be checking every number which is prime or not. Now let's say if we want to check from 1 to 1000, what would be the time? After that, now comes the basic part. Now we need to think that in the field of competitive programming, the word TLE error, time limit exceeded error, is damn important. So we need to know the basic terminologies or the basic processes of calculating the time complexity of a program. The time complexity of a program can be affirmed. Now, what are time complexity of a program? Time complexity is nothing but it is the runtime of your program. See, if you have a mobile of 4 GB RAM, the game would be running, a particular game would take to run in that mobile is 5 minutes. Now if you run the same program in a 2 GB RAM phone, the processor absolutely matters, but here I'm taking the account into RAM. So in the layman's language, because RAM is considered more useful than the processor, well, if you run the same program in an inferior device, the program would take to run 10 minutes. Okay. Now, the execution time of different execution time of different programs on different machines are different. The execution time on my program with the execution time of this program, the execution time of this program in my computer might be of 1 ms. In your computer, it might be of 2 ms, or it might be of 0 ms. Okay. Now comes the basic part that we need to generalize this. If we can't generalize this error, wait, let me see. Yeah. We need to generalize how to calculate whether the program is taking how much time. We need to generalize this. To generalize this, A standard part of programming deals with the calculating time complexity. Time complexity basically refers to this. Okay, see. First we are taking an input n. Okay. Then the n is taking one, then input, and we are outputting every number. Okay, let me do a bit manipulation to this. We are taking numbers. Let me clear out the expected output. We are taking out numbers. See, int I is equal to 0, I is less than n, and I plus plus. Okay, a dash I is equal to a dash I plus 1. Okay, then for loop, and I is equal to 0, I is less than n, and I plus C of a dash, put a space to it. Okay, and then let me print. Sorry, this summation part. Yeah. So what I am basically doing is that I am taking an input. I am taking an input of array of integers. We are adding one to it. Now, the adding of one is applied to all the elements. If we give an array input of 100, the applying input of plus 1 would be applied to 100 input. If you give me an input of 10, 20, 30, 40, it would be applied to every. So in layman's language, or to be specific, not layman's language, it is being specific, the time complexity of this program is big O of n. Let me write big O of n. Now, what is time complexity of big O of n? The time complexity of big O of n means the computation process is applied to every element. Okay. Now comes a part where the computation is applied to every element into the number of elements. The time complexity of big O of n squared. Obviously, I can't show you in square. I am writing n into n. Okay, that can be n 2, n, 5, n square, n cube, n to the power 4, n to the power 5. And let's move forward. We can calculate the time complexity of this. Okay, calculating time complexity, I can't show you the whole procedure. It involves calculating time. Okay, wait, I'm showing you time complexity of algorithms. Wait, understanding time complexity with simple examples. The examples are of use to us. Okay, see, this is the print f. This is taking input. This is printing hello world. If you input 10, if you input 20, if you input 30, the input isn't getting affected by the output. If the input isn't getting affected by the output, the time complexity would be constant. Okay, so a time complexity is O of 1. Okay, now let's move forward. This is the same on I have already shown you. On square, I am searching for on square. Oh, this is also, yeah, quadratic equation. If you calculate the quadratic equation, examples, wait, I'm showing you the example. Time complexity examples of on square. Every time complexity. What is time complexity? using constant time, order, event, lookup date. I'm interested only in ON square. Yeah. See. Oops, sorry, this is written in JavaScript. If you don't know JavaScript, this will be a hell lot of problem. Time complexity, 8-step complexity. I'm interested in
entries would be processed in slightly and will display the runtimes in the
yeah. So what is this basically? Oh, you won't can't understand this. Wait, live. Live, you can see. Wait, I'm only showing you. See in int n1 comma n2 c in n1 dash n2 int k dash n1 dash n2 for loop int I is equal to 0 int I is equal to 0 I is less than 1 I plus plus we get into the loop of it for loop int j is equal to 0 j is less than n and j plus plus c in a dash n. So what is this? This is a program. This is a program of a 2D array to take input in a 2D array. Now this program takes an input. This see for every I we are running for every I we are running a loop of j, which is from 0 to n. For every ith element we would be running a loop of j, which is of n. So the time complexity of this program would be O(n) square. If we take an input of 3D, it would be so. In layman's language, if you find a nested loop of 2, the time complexity would be O(n) square. If you find a nested loop of 3, the time complexity O(n) cube. Okay, time basics of time complexity is done. And time complexity plays after that you will be learning. Okay, so now we would be learning about a special type of program known as prime SCIVE prime c new.cpp. Okay, we already saw how to know if a number is prime or not. Now let's say if I say give me the prime numbers from 1 to 20. To be specific and short to explain you, I'm taking you the range 20, but the range can be 1 lakh also. Now we would be taking an input 1, for we would be running a loop 1, we would be testing it for 1. If it is prime, no, it isn't a prime, so not. If it is a prime, we would be outputting it. But the solution to this would be O(n) square, because for every number we are checking it. For every number we are checking it. So if I tell, let me print you 1, 2, 3, 4, 5, 6, 7, 8. Let me maximize it. 8, 9, 10, 11, 12. Let me be till 11, 10, 11, Suppose we want to take a output of a number which we want to take out the prime numbers from 1 to 20. The range is this. Now instead of checking one by one, what I can do is, first I would be marking 1 to 20 as all the numbers. Let all the numbers as prime. Okay, first we would be marking all the numbers as prime. After that, mark 1 as not prime because it is an exceptional. To mark 1 as not prime, we would be marking it with yellow. Okay, this is not prime. Okay, the composite numbers would be marked with yellow, and the prime number would be marked with white. Okay, the 1 is already marked as a composite number. 2 is marked as a prime number. So what we would be basically doing that a number which has a composite number has a multiple of prime number. Okay, so 2 is marked as a prime number. Okay, so the multiples of 2 would be marked as a composite number. So 4 should be marked as a composite number, 6 should be marked as a composite number, 8 should be marked as a composite number, 10 should be marked as a composite number, 12 should be marked as a composite number, 14 should be marked as a composite number, 16 should be marked as a composite number, 18 should be marked as a composite number, 20 should be marked as a composite number. So let's move forward with the loop. 3 is already marked as a prime number. So multiples of 3 would be marked as composite number. The multiple of 3 is 6. It is already marked. So we won't, if it is already a composite number, we won't do anything. Let's move forward to 9. 9 is not marked as a composite number, so we will be marking it. 12 is already marked, 15 isn't marked, so we'll be marking it. And 18 is already marked. So 4 is a composite number. Nothing to do. Composite number need not to be handled. We are only concerned with the prime numbers. 5 is a prime number. So multiples of 5 should be marked as a composite number. But as the range is small, 10, 15 and 20 is already marked. 6 is a composite number, nothing to do. 7 is a prime number. Okay, so multiple of it should be marked as a composite number. 14 is already marked. Okay, moving forward, 11. Multiple of 11 isn't present in our range. So nothing to do. 13 also, 17. So only in one incomplete iteration of n, we are calculating prime numbers from a given range. So the time complexity of this program is O log n. Okay, and what you have just learned the technique. This technique is known as prime sieve. Okay. Now, where to implement it? To implement it, this is the basic algorithm chart. Now comes the part to implement it. Okay, let's move forward. First, I would be writing you my template. Then, first the range would be given. Int n1. If left range, comma right range, say in left, right. Say in left, right. Sorry. Wait a second. Sorry for the network issue. So let's move forward. Okay. Range is inserted and the right range is also inserted. Okay. Then comes the part prime C. We need to implement the prime C. Void prime SCID prime C in N. So a number would be given and the prime numbers from 1 to that number is to be printed. Our objective is that. So let's start off int a dash n plus 2 to have a safe side. Int. Then we would be initializing every digit as a prime number. So for loop I comma 0 comma n plus 2. The for loop is I am using macros to reduce the writing about for loop. So moving forward, I would be marking every index as true, 0. Okay. Then I would be marking 0, a dash 0 and a dash 1 as false. Okay, because it isn't a prime number. Okay, then comes the part for less I comma 0 comma n plus 2. If a dash I, if it is true, then we would be running inside the loop. If it is true, then we would be running inside the loop. Sorry, my bad. The time complexity of this program is n log n. I forgot. It is not log n, it is n log n. So if a dash, if it is prime, then what would be doing? For loop int I is equal to I into 2, I is less than n plus 2, and I is less than n plus 1, and I is equal to I plus eta. Is everything fine? Int a is equal to for loop I and is equal to 0, I is equal to 0, n plus 1. If a dash I is equal to 0, for loop we would be getting it inside it. So getting inside a dash j would be marked as 1. Then we would be iterating it in the loop I comma 0 comma n plus 1. If a dash I is equal to 0, C out a dash I accompanied with a space to differentiate. Okay, So Bayard prime if int a dash is equal to n plus 1, I is equal to 0, n plus 1, a0, a1 is equal to 1. This is a for loop which basically if the number encountered is a prime, then the multiple of that number should be marked as a composite number. J is equal to j is less than n plus 1, I is equal to a plus ai is equal to j plus ai, the number itself, a dash j is equal to, okay. I am a king in making mistakes, but can't help. Input of 20, let's see what it is getting an output. We didn't call out the function. I told now I am a king in making mistakes. See, int a dash I n plus 1 if a dash I, everything looks good. If a dash I is equal to 0, then j is equal to all again j is j is equal to j plus I. Yeah, after a series of successful mistakes, I am heading towards this. Okay, let me check. 2 is a prime number, 3 is also a prime number, 11, 3, 17, 19. It is working fine. So, this is the implementation of the prime sieve. Okay, moving forward. Now comes a basic program to calculate HCF. Okay. To calculating HCF, we need to find out the divisor we need to find out the divisor we need to find out the greatest divisor which divides both the number. We would be incrementing the counter, and the last updated counter is known as the HCF. But this is the basic program. I won't be explaining because the time is too short and the workshop is only of 2 days. Okay, so if we move forward, there is an algorithm to find out the HCF of two numbers 2, which is known as Euclidean algorithm. Now, what is Euclidean algorithm? Euclidean algorithm is based upon the properties that, let me show you, it is based upon the properties that HCF of two numbers isn't affected if we divide the smaller number from the larger number. Suppose we need to find out the HCF between 25 and 30. If we subtract 25 from 30, the output is 5. Now 5 is the smaller, so 25 minus 5 is 20. 20 minus 5 is equal to 15. Still it is the greater. greater minus smaller 15, then it would be 10, then it would be 5, and then it would be 5. If both are equal, then subtracting, we can subtract either one, and it would equal to 0. If one number is 0, then the other number is 5, and the HCF of 25 and 30 is 5. So it is based on the algorithm that if we subtract a smaller number from a bigger number, the HCF won't be affected. So what we are basically doing, that we keep on subtracting till one number becomes 0. If one number becomes 0 and the other numbers, it turns to be out to be an integer, the integer that is returned is the HCF. Okay, you can do a run through of various other examples too, and I would not be taking much into concern. Okay, my basic part is the implementation part. This is the run through of the algorithm. You can search it about in Gigs for Gigs. Then, in the field of computer science, subtracting one number from the other number. Suppose we are giving an input of 250 and the other number is 5. We already know that the HCF of these two numbers is 5. But if we keep subtracting the smaller number from the bigger number, we would be doing a hell lot of calculations, because 5 into 5, we would be doing 50 calculations to get to the result of HCF. So what we would be basically doing is that we would be applying the modulo operator. The modulo operator, or the remainder operator in layman's language, is taken into account to calculate the HCF of two numbers. See, the implementation of Euclidean algorithm is damn easy. HCF dot cpp, then template int n1 comma n2 c1 n1 dash n2. After that, we need to write a function int HCF int a comma int b. If a is equal to 0, return a, else return HCF b percentile a comma a. As I said, I produce a hell lot of mistakes. So first, let me check with my input. Cout HCF of n1 comma n2, saving it and then printing it. HCF of int error while compiling. What is the error? Secure refresh. Okay, as I told. Okay, 250 and yeah, it is working absolutely fine. Let me check it for others too, and then I would be explaining what I have done. No, this isn't providing me the desired input. If A is equal to 0, return B percentile A. I am making some minor equilibrium algorithm. Is there a mistake in this? I can't find any mistake in this. Just I think the name of the file is clashing with this. The name of the file and the function name is this will be the function call should also be called this will be the system sorry my bad here please bear with me. Yeah, the function name was clashing with the file name. Okay, then let's move forward. What I've basically done is that if one number becomes 0, the other number is the GCD. Okay, and this is a recursive call to the same function. We are using the modulo operator because if the number is far greater, let me show you the run through of this program. Okay, so 4,16 F10 A is equal to 4, B is equal to 16. So basically it won't return, it would jump to the other statement. Now A becomes 0 and B becomes 4. In just one iteration, it gives out the 4 value. See the locals part in this. F10, then return this return would be completed and return 0. The program terminates. Okay. Then I haven't shown you now what is C++ STL, Standard Template Library. I would be just giving you an introduction to C++ STL. C++ STL is basically that after you have learned linked list, stack, queue, linked list, stack, queue, set, multi-set, unordered set, everything, after you have talked about basic data structure, that is to be implemented and then run. See, after learning data structures of stack, queue, linked list, set, map, hash map, if we come across every time in using of that data structure, every time if you use that data structure, those data structure need not to be implemented again and again. The algorithm, the main C plus STL already has. See, what is the use of C plus STL? Wait, let me show you. Let me give you a run through of C plus STL. Wait. Int n is equal to 5. Int a dash n for the equals I0 comma n C in A dash I, and for less I comma 0 comma n C out A dash I, we would be giving 4, 8, 9, 4, 6 and 5. This program basically takes an input of 5 integers and produces an output. Now, suppose the integers given are arranged haphazardly. Suppose I want to sort them in ascending order. To sort them in ascending order, we need to implement bubble sort, which has a time complexity of something, and then a selection sort or insertion sort or the sorting type of algorithm. But in the field of competitive programming, if you want to sort an array in the middle of a program, you won't be implementing the same sort function again. C++STL already has some shortcuts to it. We just need to write sort a comma a plus n, and then if we run the program, see, in just a single half written line, the array is sorted. The insertion sort or the bubble sort would have taken 15 to 20 minutes. But using the C++STL, we can directly sort the elements in an array. Okay, let me show you other powers of C++STL. Suppose I need to work with a particular number, but the amount of number we would be calculating isn't given. Okay, suppose here I have fixed the array. If you come across linked list, if you learn about linked list by yourself, you would be knowing that array has a fixed size, but linked list has a variable size. So implementing linked list and then using it would be a hell lot of problem. But implementing linked list in using C++STL boils down to only one. This is a vector which acts as a linked list. You can use doubly linked list also. That is dq of int and dq. Then we can give it input and output, and this dq is a variable size. You can already use it. You don't need to implement it. The stack can be implemented using this. See, stack is implemented. Q can always be implemented by this too. Q. Okay. Then int a comma b c in a dash b c out max of a comma b 1,4. Let's sort it like that. See, what I am basically doing that is the use of C++STL. I am printing the max between two numbers. And if we want to print the minimum of two numbers, sorry, where it is gone. Oops, sorry, I closed it by mistake. Open file, empire, not empire. Let me use the prime signal only. Okay. So we need to write int x is equal to max of a comma b. This would assign the max element between a and b to x. Okay. So that's all for today. We can use swap also, we can use list also, priority queue, DQ, all can be done. Okay, that's all for today. And the syllabus, after you have successfully watched the 2 sessions of my forum, the syllabus would be checked upon the understanding of prime sieve and the Euclidean algorithm, and some basic modular arithmetic questions would be given. Okay, that's all for today. Me, Siddharth Hazra, signing off, and thanks for your concern to watch this video. And if you show your interest more, I would be giving you forward with this forum, and I would be continuing my forum on C++ competitive programming. Okay, that's all for today. Thank you. Good night. Have a nice day.